Okay, I think that's probably everyone who's going to join, unless there's some stragglers, but we maybe kick things off. So listen, thanks everyone for joining the session on foundations of cloud security. What we're going to do is just go through just a quick agenda of the webinar today. So I've got a couple of slides just introducing CWSI to those of you who haven't come across this yet. I know there's a bit of a mix of some companies who have worked with us in the past, current customers, and also some people who maybe have not been aware of us. The agenda, obviously, we're going to go through the foundations of cloud security, the shared security model, shifting left, which those of you in the DevOps teams will be happy to hear about, the importance of runtime and cloud workload detection and response. So how we're bringing those sort of EDR technologies to cloud workloads. Then John is going to do a live demo and walkthrough of the SentinelOne Singularity platform, obviously relating to the cloud module. And then we're going to open the floor up to some questions for a Q&A. So hopefully we're going to get some bit of discussion there about how you guys are managing cloud security, the challenges you're having with obviously the DevOps, SecOps teams, and how to sort of build a cohesive strategy for that. So just to introduce everyone to CWSI, my name is Marcus Twitchett. I'm the Enterprise Mobility and Security Solutions Specialist at CWSI. We are key focus partners for SentinelOne across the UK and Ireland. And it would be great if we could connect through LinkedIn, share some stories, and get a chat in that platform. So just to give you a little bit of background on CWSI as a company. So we started in 2011. We're initially formed and based in Dublin, Sandyford. And we basically helped companies start with securing their mobile fleet, 10 years ago. So the first, well, not the first, but at least the sort of second generation mobiles, Blackberries, Samsung devices, etc. Everyone was bringing into the workplace. We were helping, secure and manage those devices for companies, and having them access to a centrally managed platform, such as an MDM platform, as it was known back then. So now, obviously, things have changed a lot. A lot of companies are on their digital transformation journeys. They're leveraging the cloud, obviously, for cost savings through SaaS-based subscriptions, and also using, leveraging that for faster code deployments. That also brings challenges with managing this from a security and compliance point of view. So our service offering has greatly extended out to those services as well. So we're very much mobility and cloud-based now. We've made a few strategic acquisitions over the last couple of years. Blauw in the Netherlands, Melco in Belgium. So we're increasing our footprint through Europe and extending out our capabilities across those areas. So our goal is to sort of really become a pan-European mobility and security player, which we're doing now with 5 European territories in place and very much a global customer base that we have now. So CWSI, what do we do? Okay, so what we do is that we are cloud and mobility experts, and we deliver cloud and security compliance services for mobile and remote working environments, which is sort of now extending out to the whole modern workplace ethos. Just waiting for a couple more people to come in there. So employees should be able to access business applications in a secure and compliant way from any device and any location. So our aim is to keep you secure, or get you secure and keep you secure. And this is done through, obviously, security compliance, security assessments, managed deployments as well. So this often starts with security assessments and workshops. So we want to be able to get get you to understand what your business drivers are, bringing your compliance and security strategy to fruition. And we also want to know what your current baseline is and what sort of security framework or standard you're working towards. So this could be CIS, NIST, ISO 27001, or specific frameworks such as PCI DSS, for example. And then we bring those solutions. Once we have a baseline, we'll work with you to build a solution design and really help you deliver this as well. We can obviously offer a fully managed service around that to keep you secure and compliant to that baseline and framework, or we can sort of become sort of an augmented part of your team as well. So, we're very much security agnostic, so we'll sort of use and leverage the security that you have inside your environment, and build a process of hardening that with you and your team. So we have tried and tested sort of methodology around that, and we have very much a growing customer base of sort of logos and names that you would have seen across the different verticals. So that's a bit about CWSI. Obviously, we'd love to get a chat with you at some point about some of the security projects you're working on, see if we can offer some alignment with our expertise. So I just want to introduce the guys now from the S1 side. So we have Bunesh Rajput, who is a EMA Cloud Specialist for S1, and John Peace, who's a EMA Cloud Security Engineer. Bunesh is going to sort of go through some of the initial slides. So I'm going to pass it over to Bunesh.
Thank you, Marcus. Nice to meet you all. Thank you for taking the time and sort of jumping on this webinar with us and talking about cloud security. So I'm going to try and figure out how to share slides now. Bear with me to do this. Teams is not very friendly these days. Okay. Cool. Let me know when you can see my slides. It's still loading. There you go.
There you go.
Perfect. Thank you. So before we jump into the good stuff, let us remind ourselves, what is the goal of cybersecurity? It's very simple. As professionals, we want to ensure what we build works as intended and only as intended, right? Now, to put this goal into action, we do a couple of few things. We try to be more proactive. We try and find weaknesses in our security before they're exploited. But we try and find the right balance between safety and efficiency. Obviously, we don't want to be too secure at the cost of growth and innovation for our businesses, right? We plan for trouble when things don't go right, when things go wrong. And obviously, we manage risk. Now, our goals don't change whether we are fully on-premise, we are fully in the cloud, or we running sort of a hybrid environment. What changes is how we achieve our goals, because things are inherently different in the cloud. Now, this same principle applies to on-premise versus cloud security, or endpoint versus cloud security, because inherently cloud is a very different environment. Now, in an on-prem environment, or when you're securing your endpoints, we control all aspects of the endpoint or the data center, all the way from the hardware, the people, the tools, the software, everything else in between. Then we put a perimeter security around it and we lock it down. Now, in the cloud world, things are different because we share that responsibility with our cloud service provider. Now, this is called a shared responsibility model. You guys, some of you might have heard of this. It's quite popular. But what it basically means is you share some of the responsibility with whoever your cloud service provider is. And your cloud service provider is responsible for security of the cloud, which includes the hardware, the hypervisors, the switches, the routers, all of those things which make up this new environment. Now, as a customer, you are still responsible for the stuff that you put in this new cloud environment, and that is your responsibility. Now, this includes your workloads, your data, your applications, and obviously you still have to manage your configurations, your credentials, the network, etc. Now, this is where personally, we have seen the biggest risk. especially when it comes to resource misconfigurations or people having too much access to certain things. To give you a few example, even from this last month, we had Rockstar games which were hacked, and Uber obviously is a good example of that. In both cases, very simple breaches because of resource misconfigurations and user credentials. Now, the key takeaway here is that although you share the responsibility with the service provider, you still have some responsibility on things that you have to control. Now that takes us to what are the service models? How do we consume cloud? Obviously, you have your traditional on-premise, where you run everything. You have all these different things you do on a daily basis to run and keep it up and running. Now, if you go all the way to the right, you have a software as a service model where you don't control or secure a lot of the things. You're not responsible for that, but you still have data and user access. What that basically means is, regardless of where you are in your cloud journey, you might be on your way to the cloud, or you might be fully mature in the cloud, or you might be in a SaaS model. You still have some responsibility. What I've done is I've simplified some of the key focus areas that you can focus on when it comes to that security. And there are 4 key areas that I think of should be key for any secure environment. And the first one is networking. Now, we want to see and monitor all communications between services and assets, right? And in order to build a perimeter security for the cloud environments, we want to maximize the cloud networking services or cloud native services for networking, which are made available to us. Now, some of these services such as, are like structures in Google Cloud, or could be transit gateways or VPCs. Now, all of the service providers have this idea of a virtual private network. A VPC can give you very strong boundaries. Most of the time, these services are free to use, so you can have multiple VPCs running at the same time. This is a very simple way of running applications in the cloud. One VPC, one action, and you can control and secure it from a network perspective. This is pretty good. Now, the key here is to understand that all these services like VPCs and security groups and etc., there are a lot of services available to you when you move to the cloud. These are all really good services, but they are all there to allow you to understand how system A talks to system B. What they don't do is they don't give you the contents of that communication, which is usually where the gap is. What you want is you want a system in place which would allow you to understand the content. Some of that, systems in place, you can use IPS systems, for example, or you can implement micro-segmentation to have very granular control and rules for your networking. So in case if there was an attack or there was a breach, you can curb the lateral movement. So that's the first thing of focus. The second most important thing is network or compute security. This is something which John and I work on a daily basis. Now, running workloads in the cloud is not as different from running workloads anywhere else, really. But in the cloud, you are given a lot more options. You have more choice of what you can use. So, for example, you can use servers, VMs. John mentioned, essentially what you can do is you can lift and shift. You can bring all of the on-premise stuff that you had onto the cloud, but you now have option of running workloads such as Kubernetes and containers and build microservices. The key here is to understand the responsibility line. Who is responsible to secure these new workloads and how to secure them? And John is probably going to cover some of that later in this presentation. And it's very important to understand that these workloads might be Kubernetes, might be microservices, shouldn't be treated differently from your traditional environment, your traditional infrastructure. So you should be doing autonomous EDR. You should be managing those workloads exactly the same way you have done things previously, because again, this is an extension of your environment. The other thing you want to think about is, data and storage. Now, this one is quite obvious. We need to secure the data, and it includes databases, cloud storages, S3 buckets, Azure security, storage blobs, etc. It doesn't really matter, but the idea is that you should be able to encrypt your data at rest using all of the cloud native security features available to you. But additionally, you should scan your data for threats, malware, and ensure that any of the PI personal information is secure. The last bit of information is, to how to secure identity and access management. Now, you obviously want to lock down this environment, and you want to understand who have access to this environment. There are many different ways you can do it. Again, you can use third-party solutions, or you can use cloud native services. but you should be able to control who goes in and out. And if something suspicious happens, you should have visibility into that. So if you do all these 4 things, you should have somewhat of a robust security environment. And between S1 and CWSI expertise, we can certainly help you secure all of these services out of the box. Now, obviously, we've been talking about security and how it's different from on-premise, but the cloud is modernizing everything. It's also modernizing software development lifecycle, essentially how we build things as well. We have seen, everybody moving from waterfall to more agile approach to software development. We have seen companies building more, moving from monoliths to building microservices, smaller applications, releasing those applications or having more frequent releases, moving to more DevOps model of development. It's all good because essentially what these companies are doing is they are successfully modernizing. And those companies who are successfully doing it are, they all have one thing in common, which is they're doing shift left, which, loosely translates do things early and do things often. That's essentially what shift left is. You basically applying this idea to software development that if you are coding early, building early, testing early, doing staging and deployment more frequently, more early, then you should be able to have security checks in them, and then you will be building things secure by design. So by moving things left, you are going to be building things which are going to be secure by design by leveraging cloud native services. It all sounds pretty good because it allows you to deploy at speed and do things more frequently. But as we all know, speed comes at a cost, right? And that cost essentially is having gaps in your security posture. Now, I'm all for shifting left, and I think doing things early and doing things often and building things secure by design is a very good thing. And I think this is something which we all practice. However, I don't think this is a complete story because working with organizations, working with companies, what we have realized is that having this shift left approach, it's a very point in time solution. Because a lot of the time we are putting the responsibility of security on the shoulders of development teams and DevOps teams, who a lot of the time don't have the expertise in that domain. They lack centralized government or governance on development pipelines or whatever other development might be happening. We obviously know about the zero-day attacks, and we know that it's very much depending on humans doing the right thing. So what we are essentially saying is, it's a very simple idea. The execution is very different because the evidence is in front of us, right? I mean, 3 out of 4 containers running in production today in the cloud, they all have severity or severe vulnerabilities. So what is the way? How do we protect these workloads? What is the full approach? What is the end-to-end approach that we should be looking at? This is where I'm going to pass it on to John to kind of talk about what is the other approach to DevSecOps. How can we secure these workloads running in these new environments all the way from development while they're running in production? And what is the importance of EDR in the cloud and why runtime defense is so important? So with that, John, over to you.
Excellent. Thank you, Banesh. So if you can just stop sharing your screen and I will briefly share my screen. If you can just let me know when you can see my screen.
Yep, we can see your screen now.
Perfect. Thank you for that. Excellent. So thanks for that, Banesh. So one of the things that we do during the build cycle when we're building out cloud workloads is that we scan for vulnerabilities. So we scan images for vulnerabilities. And as Banesh said there, that's a point in time control. So I thought I'd just start by looking back at the life cycle of a vulnerability. So a vulnerability can exist for a very long time. The particular vulnerability that we're looking at now is something that was which was referred to as shell shock, or better known as shell shock. That was actually a bash vulnerability that was within the bash code from 1989, so a very long time ago. But it wasn't until a security researcher started probing this particular piece of functionality within bash that they were able to identify that there was this vulnerability. And that wasn't until 2014, so 25 years later. So whilst scanning for vulnerabilities should absolutely be done as part of your sort of approach to security, it is only a point in time solution. And this is where extending that capability or extending controls into doing runtime protection is really important. So if we look at the sort of the DevOps and SecOps, and so when those two teams kind of come together, the goal really is about the reduction of the attack surface, and we can reduce the attack surface in a number of different ways. We mentioned earlier there that, you know, you can scan the image for vulnerabilities, and then, again, as I said, that's a point in time control, and it's based on what you know are known vulnerabilities. Then what you can do is you can scan for configuration issues. Both of these controls give you the ability to say with reasonable confidence that you're ready to deploy your workloads into the cloud environment. From that point, you then need the runtime protection. So in an ideal world, where possible, you should be able to effectively make your cloud workloads immutable. So in other words, as you've deployed them, they should remain as they were deployed. So nothing can be added to them, and nothing can be executed from that particular timestamp, for it as an example. So there are many approaches to this. Some organizations use whitelisting and blacklisting. Our particular approach at SentinelOne is actually to take the timestamp from the deployment and say from this point on, nothing newer than that timestamp can actually execute within the cloud workload environment. The next thing is the runtime defense. So what we need to be able to do is we need to be able to track everything that's happening within those cloud workloads in real time at runtime. So we're able to identify, using behavioral analytics, what is actually going on within those cloud workloads. But more importantly, once we identify that something is wrong, that we're able to take an action, and that action should be able to be automated. So we don't want to flood the security operations team with a number of alerts from the cloud environment. What we want to do is effectively make the cloud environment autonomous to the point where it can accurately provide that runtime defense. Then what we need to do is we need to send all of the behavioral information into a console where we can apply threat hunting techniques, so extend that threat hunting. And Banesh and I, when we're talking to customers, you know, large organizations that have security operations centers who are doing proactive threat hunting, they always see the cloud environments as a very sort of almost like a dark corner that they don't have visibility into. So this is all about getting that visibility into the security operations center, which enables them to then do that kind of proactive threat hunting and include the cloud environment. So really what this is all about is a cloud defense in-depth strategy. So as part of that strategy, we talked about image scanning, we talked about making sure the configurations are secure. And Banesh talked about it earlier very briefly around identity and access management. So we need to adhere to those principles of least privileges. We need to make sure that we guard those privilege accounts, but we also need to be continually reviewing the identity and access management privileges to make sure that as individuals have moved into different groups, that we're able to then make sure that the things that they have access to now are those things that they should have access to as we move them into different groups. And then as we move on to the right hand side, with the architecture, it's all about designing security into that architecture from the ground up. And so most of the cloud service providers will have effectively kind of security templates and reference architectures, which will include a lot of their products. but it will also include independent security vendors, so ISVs. And so what they do is they add in additional layers of security that the cloud service providers can't natively provide. And we are one of those independent security vendors. And what we do is predominantly we provide this runtime protection, so this proactive runtime protection. And runtime protection is not particularly easy to do. You know, when we look back in time and we look at, you know, endpoint protection and EDR and endpoint detection and response, it's quite difficult to sort of identify what does something look like versus how does it behave. So what we developed at SentinelOne is we developed something called a storyline. So if we think of everything that's going on within a cloud workload as effectively all of the processes, child processes, grandchild processes, and then interactions between processes, if we think of those as stories which are evolving, our objective and what we've done within our behavioral engine is we've developed a system where we can actually track those stories as they evolve. So we track them from the very beginning. We're able to identify exactly what's happening at every single point during that storyline, which means we can accurately identify when something becomes, say, suspicious or malicious. And also because it's at machine speed, we can then identify everything that happens thereafter. The key thing is the thing that links it all together is the storyline identifier, because that gives us a source of truth as to where this particular story actually originated from. So this then gives us the ability to surgically remove that story from all of the other stories within the cloud workload. In the terms of, say, containers, for example, so containers running on Kubernetes clusters. Kubernetes has mechanisms to automatically respawn containers if containers are killed. So if we killed a storyline which involved a particular container, that would kill the container, and then Kubernetes would automatically spin up a brand new container. So that enables us to effectively not disrupt the application and the availability of that application in real time and at runtime. So what does the SentinelOne solution consist of? So we have an agent for Windows workloads, we have an agent for Linux workloads, and we have the agent for the Kubernetes environment. But what we also have is we have an agent for S3 buckets. So as organizations are utilizing S3 buckets for storage and giving customers the ability to be able to upload artifacts into those S3 buckets, what we can do is we can scan those files, and we can do a couple of different things. So we can either quarantine a file if we believe that it's either suspicious or malicious, or we can even tag it, you know, so we can tag it, and then you can use the access control capabilities within the cloud and say certain groups and certain users can't access files if they're, or objects if they are specifically tagged in a certain way. And the way we do this is using our machine learned models. And so what we do is anything that's saved to an S3 bucket, we will actually pass it through our machine learned models to determine is it suspicious or is it malicious. The other thing that we do is that we have an integration with the AWS Security Hub where we can send security events and all of the risk information into AWS Security Hub, which then gives AWS customers the ability to centralize that security view in the Security Hub. And we do all of this with a single management console. So rather than you having multiple management consoles and analysts having to jump from one console to another, we can do this all within a single management console. One of the key areas that we're seeing in terms of growth is the containerized environments. So where organizations are moving to the cloud and some organizations are doing lift and shift, so they're taking their virtual machines from their on-premise data centers, and then they're effectively spinning those virtual machines in the cloud environment. We call that lift and shift. So we're seeing some organizations doing that, but the more forward thinking look to re-architect. So they're looking to get all of the benefits from the cloud, from the scalability perspective, from the resilience perspective, but also the full automation of the cloud. They're looking to re-architect their applications into containers and containerized workloads, because it enables them to accelerate their development lifecycle, as Banesh said there, is accelerate that. And so cloud really should be an enabler, and this is why people are moving more into that containerized environment. So our agent for the Kubernetes environment gives us that runtime protection that we were just talking about there, with the full storyline of everything that's happening. But it also gives you the ability to take the flight data, and we call it the active EDR data, together with additional context from the Kubernetes environment. So, for example, the cluster, the node, etc., and all of that information together with cloud metadata. So which cloud environment is it running in, which zones, etc., and what labels are associated with that particular node, pod, and also the container. What it also does is it extends the ability to do threat hunting and include the Kubernetes environment. So if you're looking for, say, a file hash, and you're looking across all of your endpoints, you can look across all of the endpoints, but then also look at all of the cloud workloads that you've got running. So EC2s, the containers, etc. But during an incident response, we also give you the ability to do a two-factor authenticated remote shell directly into a pod. So when an analyst that needs actual hands on the keyboard in a pod or a container, they can do that. So they can then do some more investigation. They can effectively save that transcript and save that back into the management console, and that gives them that information to then make a more informed choice as to what to do about this particular threat. So from an operational benefit, it's a single console for Windows, Mac, Linux, and Kubernetes environments. And so it's that single place where we can define policy, we can organize a hierarchical structure where we can inherit policies or have specific policies for specific environments, but within a centralized management console. All of the alerts are coming in, all of the dashboarding is within that single management console. We use cloud native tooling to install the Kubernetes agent via a Helm chart. The agents are lightweight. And from a Kubernetes perspective, when we were deciding how to secure Kubernetes environments, we looked at many different mechanisms. So one of the methods is to effectively be as a pod or a sidecar on a pod or a container. But the challenge there is then that means that we have to be involved in the build pipeline. So our agent needs to be considered when you deploy a new application or a new pod or a container. So what we decided to do was be effectively a daemon set. And so we deploy once to the cluster and we auto scale with that cluster. So as the cluster expands and contracts and new worker nodes are introduced, our agent is automatically deployed. When customers deploy a new application in a new pod or a container, we're automatically providing that protection. It's not something that we have to then build into that kind of DevSecOps. We deploy once and then it's automatic, provide that automatic protection. What I thought I'd do is just a very short kind of runtime protection demo of how this actually looks in the real world. So if I move across into my lab environment and I go across to our management console. So when we deploy our agent to the Kubernetes cluster, we gather certain pieces of information. So if I get into this particular node, we get the cloud information. So we get the cloud metadata. So we get the Kubernetes information. So the type of cluster it is, the cluster name, any node labels, and also any cloud information. So AWS information. So the location, etc. but also tags that are created within those cloud environments. What the tags enable us to do is effectively create what we call dynamic groups. So when we deploy to the cluster, we take those tags and then we're able to then assign the nodes to specific dynamic groups and then control the policy that's applied to them by those dynamic groups. So in my instance here, for example, I've got a dynamic group here, Kubernetes dynamic, and my policy is currently set to for suspicious, where we have a reasonable AI confidence, we're set to detect only, but where we have a high AI confidence, we're set to protect. And so if I go across to my my instance page, and we see we currently have no incidents. What I have is a web application which is running within a pod, and so this application is a web testing application. So when I log into this, we can see that this is actually a brand new container because it's sitting at the setup check. When I hit create reset database, what that will then do is go away and create all of the backend data so that we can then utilize this testing framework. What DVWA enables us to do, specifically when it's running in a containerized environment, is to test the security of the containerized environment, not the access into that environment, but actually test it from the vantage point of being an actual container. So in this particular instance, we've got the OWASP top 10 on the left-hand side. In this particular instance, I'm going to go do a command injection. So in terms of command injection, this web page should only really take an IP address. So when I hit submit, it should say, okay, I'm going to ping that whatever IP address you put in here and produce the results within this web form. But what we're actually going to do is a command injection. So we're actually going to ping localhost 4 times, but then we're going to append an action. And the action is actually to download a script.sh. We're going to output it as script.sh. We're going to chmod it to make it executable, and then we're going to effectively run that script. What this will do is this script actually is designed to pull down a known piece of malware, and this is gives you the ability to or gives us the ability to identify this via our global threat intelligence. So we can see that, you know, we can identify it and we can very quickly stop it. Then we're going to pull down another piece of malware which has been modified. It's had some bytes changed within that piece of malware, and so therefore we have to put it through our static AI engine to determine is it suspicious or malicious. So now if we move across to our management console, and I'll just do a quick refresh here, we should have a number of alerts in the console. So we can see here there's Doki. So Doki is a known piece of malware. And on the right-hand side here, we can see we caught this on the SentinelOne Cloud. So that we caught this via our global threat intelligence. And if we go into that, we can actually see that it has a high AI confidence, and we automatically quarantined it. So we quarantined it in less than 100 milliseconds. So now if I go, and then we've got our Doki random, this is where we put Doki random through the on-write static AI engine. And we can see also the green tick there to say that was automatically quarantined. The last alert we have in here is for curl. So when I go into curl, we can see here that this is an AI confidence level of suspicious, and that we caught it on our behavioral AI engine, and we caught it dynamically, so on execution. We can see the path, so we can see the Docker overlay path. We can see the command that was used, the command line arguments. But as we scroll down, we see additional information within this alert for the analyst to look at. So we can see the Kubernetes information. Specifically, we can see the namespace, we can see the pod, and we can also see the image that this pod was created from. So once we've done our investigation and we determine that this is command injection, we can confidently say that we need to actually update this image and remove that particular vulnerability. We also give you the cloud information, so the account information, the VPC information, and any kind of roles and security groups. So it gives the analyst a lot more context as to what's happening. On the right-hand side, the agent automatically maps behaviors to the MITRE attack framework. So when we can see 4 indicators here, so we can see a MITRE tactic of evasion, and then a technique of obfuscated script execution. But then we have the associated MITRE TTPs, or tactics, techniques, and procedural numbers, that we can then right-click, for example, and open in a new tab. And then that takes us directly out to MITRE. And within MITRE, they will provide the information of the procedural examples, but also any APT threat actors that are known to use this particular tactic, technique, or procedure. We can also see the storyline identifier here that I was talking about earlier. Now, if we want to visualize that storyline, we can go into the Explore tab. Within the Explore tab, we can see container DSHIM is in blue, and really the attack started to become either suspicious or malicious at this bash node here. And we can expand the storyline out, so we can really have a good look inside the storyline to understand exactly what's happening or happened within this particular storyline. So as we go through, we can click on any of those nodes, and we can see any command line arguments that were used. So once we're happy we've done our initial investigation, we can go into actions and then mitigation actions. And I can say, okay, what I want to do is I want to kill and quarantine anything related to this particular threat. We correlate the threat across all instances of the threat. So if this was on multiple nodes or multiple clusters, we're able to correlate that and take this action once within this interface. I'm going to mark this as resolved, and typically an analyst would put in here something, why are we doing this? Why did you decide to quarantine it? And you can, they would usually also put in some kind of ticket information. We'll mark this as a true positive, and we hit apply. So what that does is then instructs the agent effectively to kill that storyline. So actually take that storyline and kill it all the way back to the root of that storyline. So if I go to my DVWA instance here, what I'm doing is I'm running a watch on get pods in the demo namespace, and you'll notice there that pod has just restarted 5 seconds ago. So what we've done is we've killed it all the way back to the root of the storyline. What that means is now when I go back to my application, to my web application, if I click anywhere in here, it takes me back to the command prompt, and then I go to log back in. And again, we're back on, it's a brand new container. So it's a fresh container. So effectively Kubernetes has recognized that we killed the container, and has then kind of spun up a brand new container. And so I'll now move back across. Hopefully you found that demo interesting. So I'll just hand over briefly back to Banesh, who's going to cover the next couple of slides.
Thank you, John. If you can move on to the next slide, please.
Oh,
if you can share, that'd be handy.
That would be really handy. Hang on. Let me just, so there you go.
Cool. Thank you for doing that, John. So I really just wanted to spend a few minutes talking about SentinelOne as a company. Now, as John mentioned, we do these. We've been around the block. We have all these security controls and AI and all this goodness built into our platform. And the reason for that is we have been around the block for a while. Our inception was 10 years ago, almost 10 years ago. We went IPO last year. We are over 1,000 employees. We have more than 6,000 customers. Our IPO was the biggest IPO in cybersecurity. And we have, expertise and people and essentially locations all around the world. John, to the next slide, please. But really what makes us different from other vendors or other companies out there is We are truly bridging that gap between your traditional environment and what your new environment might look like. And we're bridging that gap by bringing in automation and AI. Obviously, we call it storylines, you can call it EDR in the cloud, but essentially what we're doing is we are taking data, ingesting data from all these different avenues you might have in your organization. You might have endpoints, you might have presence in the cloud, where you might be using containers, you might be using EC2 instances, you might have storage, whatever you might be using in the cloud. We're bringing stuff from identity, and then we are allowing third-party ingestions to make sense of all the data that we are bringing in. And that's what makes us different from other vendors, because we are bringing in these behavioral models and leveraging AI and automation to kind of make sense of what we're seeing in your environment. With that, I again going to thank you for the time that you've given us. We still have another 10 minutes to go, so if you guys have any questions, please feel free to use the chat box to ask those questions. John, myself, and Marcus will do our best to answer those questions for you now. And if not, then we will obviously share the details towards the end of this presentation, so you can reach out to us afterwards.
Thanks, Vinesh and John. Thanks for running through the demo. Just while everyone's sort of prepping a few questions in the chat box there, just had a couple of questions come in. So how resource hungry is the agent? I know this has been an issue with some other endpoint vendors previously, with the amount of sort of CPU usage it takes up, which can affect performance. So if you can enlighten us on that.
Yes, absolutely. So performance. So there are a couple of things that I'll kind of say before I cover that in depth. So all of the intelligence that we have, so all of the machine learned models are fully installed on the endpoint. So it doesn't rely on the cloud to send information, so we don't send information directly from our agents into the cloud, do any analysis. It's all done locally on the agent. With that said, performance is one of our biggest, one of our key KPIs, if you like. So, for example, we will typically consume sort of an additional kind of 2 or 3% CPU and probably about 200 to 300 meg of memory. In the cloud environment specifically, we can also, when we deploy to say containerized environments, we can define the number of requests and also the limits. So we can actually limit the resources that we consume in the cloud environments. So hopefully that answers that question.
Excellent. Thanks, John. Just another one there. Specifically around sort of AWS environments, running resources in EC2 and workloads in EKS. So how DevOps friendly is the agent? For example, is it auto-deployed? Does it intervene with the kernel model? And lastly, can you update your AMI, Amazon machine image, without it conflicting the S1 agent?
Yep, great. Again, a great question. So in terms of, it's very kind of DevOps friendly. So as I said, for the Kubernetes agent, we deploy via a Helm chart. Key thing for us is that we work in user space, so we don't taint the kernel in any way. So this is key, as you mentioned there, when you're doing upgrades. You don't want to be locked into our development lifecycle of the agent. By being locked into kernel versions. So when you want to do an upgrade, you don't need to wait for us to develop an agent that supports the kernel version you're going to. So we're working in user space. We have a number of different mechanisms, including one of the main ones is what we call eBPF as a mechanism to get all of the communications and understand the communications between user space and kernel space. In terms of building us, so what you can do is you can effectively create the AMI images and have us baked into those images. So when you use that specific AMI image to deploy out, and we're already baked in, it will automatically connect into the console and automatically provide that protection.
Thanks, John.
No problem.
There's one other one here. The Singularity Cloud module is an add-on, obviously, to the Singularity XDR offering, which helps extend out the security and visibility of all the assets running on the public clouds. So is this managed from the same console, or is there multiple consoles for cloud and endpoints like some other vendors?
No, it's always it's one of base. This is why we call it a platform. So it's always been one of our goals to have a single management console. So everything that we do, so I'll give you another good example is, so we also started covering mobile. So, you know, we're now integrating that mobile capability into our console. So, you know, we also acquired an organization which was a TiVo some time back. And so this is also going to be integrated into the management console. Our entire goal is to have a single console, but as Banesh was talking about earlier, when we talk about XDR or extended detection and response, we then build API capabilities where we can pull information from third party vendors via API, and also then take actions, and this is a key point, within a security alert, so you get the additional context from that third party vendor in the same alert, in the same single management console, but then you can take what we call XDR actions. So if you think about a typical attack, if we pull in, say, the Okta information, within the Okta information, we can see things like failed logins. And so what this enables us to do is that to then say, okay, I want to reset that user session and then potentially disable that user's account within Okta, but directly from our management console. Now, Marcus, that was a very long answer to a very short question. Sorry about that.
That's okay. Just want to take, is there any questions from the floor there? Is this in the chat? No takers? Okay, well, if there's no other questions, just to finish off, I will be sending out a sort of follow-up to all attendees. I'm sure that John and Banesh would be happy to set up any further sessions one-to-one with any of you if you want to explore this offering in a bit more detail and see how it can sort of fit into your current stack and environment. So I'll be sending that out probably tomorrow. And the guys will be sort of on hand to answer any questions, and I can also facilitate any further demos that you may want your sort of wider team to take a look at. So I want to thank John and Banesh from S1 for coming onto the session and talking us through the cloud security module for SentinelOne. I'd like to thank everyone who attended as well for taking some time out to learn a bit more about both CWSI and also SentinelOne. So yeah, thanks everybody for attending. Hope you found the session insightful.
Thanks, everyone.
Thank you, everyone.
Thanks a million. Very interesting.
Great.
Take care.